Hey class, it's good to be back. I just couldn't wait to start a new video on our new unit on the radical function. So when you have a radical function, you're going to have a radical. This is known as a radical. Okay. Remember that inside this little v is where you put the root. Okay. So if there's not a number in the little v, remember that means it's a 2. And that means it's a square root. So let's take a look at this example. F of x is equal to the square root of x. So this is the parent for the square root function. So let's quickly take a look at the table and the graph and the domain and the range. So for the table, of course, we're going to pick some negative numbers. And some positive numbers. And remember that when we choose these numbers, we're actually choosing numbers that we're going to be plugging into the function for x. So, so you have to do some thinking here. So right off the bat, typically we choose these numbers to plug in. But if you do some thinking here, if you plug in a negative number inside the radical, remember this is known as the radicand. You get a non-real solution, which is an imaginary number. So just as a reminder, real quick, if we took the square root of -4, just as a reminder, this is a non-real answer. This breaks down to the square root of -1 and the square root of 4. Square root of 4 breaks down to 2, because 2 times 2 is 4. And the square root of -1 is I for your imaginary part. So for these purposes, we are not going to be graphing on an imaginary coordinate plane. We're going to be graphing on a real number coordinate plane. So in this case, if we plug in negative numbers, our calculator is going to give us an error because the answer again is going to be non-real. So let's go to 0. If we plug 0 in, the square root of 0 is 0 because 0 times 0 is 0. So let's plot that first point. Plugging 1 in, the square root of 1 is 1. So 1, 1. Plugging 2 in, the square root of 2, now that's going to give us a decimal, the square root of 2. So usually when we plug numbers in to graph, we try to use numbers that are perfect squares. So let's go to the first perfect square, which is 4. And plugging 4 in, the square root of 4 is 2. The next perfect square is 9. And plugging 9 in, the square root of 9 is 3. So let's plot these points. So 4, 2. And then 9, 3. It's going to take us kind of off of our graph, but get the idea. So now we have a starting point of 0, 0, and it's going to curve to the right. And so this is what a square root function looks like. Now, writing the domain and the range. The domain is left to right, so I'm going to go ahead and use interval notation here. So we're going to start off here at 0. It's a closed dot, so we're going to use a bracket, and it's going to go right infinitely. Range, the starting point is going to be at 0 on the y, the lowest point. close dot, and it's going to go up infinitely. So there's your domain and your range. Okay, so where do the parameter changes come in? Remember, parameters are what transforms the parent. Parameters transform, we'll just say the graph. In this case, we'll be transforming the parent. So where do these, what are these transformations? So basically we have our A value in the front. Remember, that is our vertical stretch or compression. And the square root, the radical operates like grouping symbol. It is a grouping symbol. Okay, kind of like the parentheses in the quadratic function. Okay, so remember, whatever happens on the outside has a vertical effect, and whatever happens on the inside has a horizontal effect. So I'm going to go ahead and add on this letter here, B, times x minus h. All of this is underneath the radical. So I'm adding a new letter. We really didn't have a letter first semester for our horizontal, stretch, and compression. So now we're going to call that B. It doesn't have to be B, it's just an arbitrary letter to represent a horizontal stretch or compression. Okay? Oh boy, I just saw that my volume doesn't seem to be on. Okay, continuing on. So here's our horizontal stretch and compression. Here is our vertical, I'm sorry, I was just going to say slow down to myself. This is our horizontal translation left and right. And remember, these are always going to be the opposite of vertical. And then of course we have our K value on the end. So again, vertical stretch or compression, horizontal stretch or compression, horizontal translation left and right, and vertical translation up and down. So let's take a look. At an example. So in this case, the 1/3 tells us we have a vertical compression. I'm going to go ahead and abbreviate. Here we have a horizontal compression. Here we have a translation of 4 units left. And here we have a vertical translation of 5 units up. Now, let's go ahead and apply an example problem to the parent if we have the time here. Looks like we do. So let's look at an example. So let's take, we'll call this example 2, and we'll apply a stretch, a translation to the right, and a translation down. Okay, so let's make this graph. Hopefully I have enough space here. Okay, so the first thing we want to do is we want to take this starting point, and I call it my special point, because this is the point that we are going to translate, kind of like the vertex in a quadratic function. So we're going to take that starting point, since we're going to be transforming the parent function, which is the square root of x, and we're going to go 1 unit to the right, okay, and we're going to go 2 units down. And so our new starting point is going to be here. So we've just applied this part and this part to our special point, our starting point on our square root function. Next thing is we're going to apply our vertical stretch. And the easiest way to apply our vertical stretch is to take our table and multiply all of these numbers by 2, because they're getting stretched vertically. And remember, vertical is our y coordinate. So if I multiply all of these by 2, we'll have our new y coordinates. So we're going to have 0, 0 still. But remember, our new 0, 0 is not at 0, 0. Our new 0, 0 is at 1, negative 2. So this is our new 0, 0. So from our new 0, 0, if we go 1 unit to the right, we have to go 2 units up. So from our new 0, 0, we go 1 unit to the right and 2 units up. Okay. Our next point that we graphed was 4, 2. Multiply that by 2. So our next point is going to be 4 to the right and 4 units up. So from our point 1, 2, 3, 4, 1, 2, 3, 4. And then 9, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. So we have our starting point, which is our new 0, 0. And it's going to be stretched vertically. And our new table, we can get that from up here. Okay, so that's an introduction to radical functions, looking at the square root function. I'll see you guys on Tuesday. Hopefully you'll have this done and ready to go. See you then.